Very good morning, dear students. Today we continue with chapter number 25, probability. Last time we discussed a few questions from exercise 25A, and today we will continue with some more complex events from probability. Before this, we will consider some more sample space. Previously we know in tossing a coin once, there are two possible outcomes, head and tail. And the total number of these outcomes we can write it as 2 raised to power 1, that is equal to 2. Similarly, in tossing a coin 2 times or in tossing 2 coins simultaneously, just keep in mind one thing, that when we toss 2 coins together or a coin 2 times, the outcomes we get will be 2. In case of 2 coins, we number the coins as 1 and 2, and in tossing 1 coin 2 times, we denote the number 1 for first throw and 2 for the second throw, and outcomes we obtain are same. And the possible outcomes are head on first coin or first throw and head on second coin or second throw, HH, similarly HT, TH and TT. So there are total 4 possible outcomes. So in other words, we can say the possible outcomes are HH, HT, TH and TT. So toss of 2 coins simultaneously or tossing 1 coin twice give the same outcomes as I told you earlier. Similarly, we can toss 3 coins together, and now the possible outcomes are 2 cube, that is 2 raised to power 8, and the outcomes are on first H, second H, third H, means head on all the 3, on first 2 H and in third T. Similarly, there are 8 possible outcomes. So in general, if we toss a coin n times, in single throw there is 2 outcomes, possible outcomes, and when we toss it n times, the total number of possible outcomes are 2 raised to power n. Similarly, if we toss it for 4 times, then the outcomes will be 2 raised to power 4, that is 16. For 5 times, it is 2 raised to power 5, 32 and so on. Similarly, we can consider the case of throwing a dice. In case we throw a die or roll a die once, then the possible outcomes are 1, 2, 3, 4, 5 and 6. Total 6. It can be written as 6 raised to power 1. Similarly, in rolling 2 dice simultaneously or 1 dice 2 times, as in the case of coin, the possible outcomes will be 6 raised to power 2. 6 into 6, 36. And these will be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5 and 1, 6. Means 1 on first, 1 on second, 1 on first, 2 on second, 1 on first, 3 on second, 1 on first, 4 in second, and so on up to 6, 6. Here you can read this box 3, 5. He explained the meaning of 3, 5. 3, 5 means 3 on the first dice and 5 on the second dice. Similarly, 6, 4 means 6 on the first dice and 4 on the second dice, and so on. For other 36, we can explain the meaning. Rolling a dice 2 times gives the same result as rolling 2 dice simultaneously. Same thing, we roll a dice 2 times or we roll 2 dice together, then the same experiment it is. And in general, if a dice is rolled n times or n dice are rolled together, then the total number of outcomes will be 6 raised to power n. It means when a homogeneous system means when a same kind of experiment is repeated a number of times. So we can obtain the total outcomes by getting the number n, that is the times the experiment repeated, to the power to that number which represent the possible outcomes when we perform the experiment for 1 times. As in the case of coin, it is in single toss of a coin, total outcomes are 2, and if we repeat it for n times, then the total outcomes will be 2 raised to power n. Similarly, in the case of dice, if we roll a single dice, the total outcomes will be 6, and if we roll n dice together or a die n time, then the total outcomes will be 6 raised to power n. Now, a few examples. Now first we take example number 8. Here 2 dice are thrown simultaneously. Find the probability that both the dice show the same number. The first dice shows 6. The total means sum of the numbers on the dice is 9. The product of the numbers on the dice is 8. The total of the numbers on the dice is greater than 9. So first of all, we will write the total outcomes. Now we know the total outcomes will be 6 into 6, that is 36, because here we are throwing two dice together, and we can write the sample space alongside. We are not required to write the whole sample space. We can just mention 1 1 1 2 1 3 and so on, then again the sign of so on, and in last so on sign, then at last 6 4 6 5 and 6 5. But we must remember that what are the outcomes, but we are not supposed to write all. Now the first case, when the both dice show the same number, then the favorable outcomes will be, it is 1 1 means same number on both the dice, 1 1 2 2 3 3 4 4 5 5 and 6 6. So favorable outcomes will be 6. So we know the formula for probability. It is favorable outcome over total number of outcomes. So it is 6 over 36, that is 1 over 6. Then the second event is when the first dice shows 6. Then the favorable outcomes are 6 1, 6 2, because with 6 every number can come. So therefore favorable outcomes are 6. Again required probability 6 over 36, that is 1 over 6. Similarly, we can consider the case when the total of the numbers on the dice is 9. Now we have to select those pairs from the sample space from here which has the sum 9. Now in first, the largest is 1 6. So 1 plus 6 is 7. Similarly in 2 and 6, 2 plus 6 is 8. So they are less than 9. So the first number exists in 3 6. It is 3 6, then 4 5, then 5 4, then 6 3. So the favorable cases when the sum is 9 are 3 6, 4 5, 5 4 and 6 3. It means favorable outcomes are 4. So required probability is 4 over 36, that is 1 over 9. Then the next part is when the product of the numbers on the dice is 8. So we have to check those from sample space where the product is 8. So out of these two, we know 2 into 4 and 4 into 2. It is 8. So the favorable outcomes will be 2 4 and 4 2. So the number of favorable outcomes 2. So probability 2 over 36, 1 over 18. And last part, fifth part, when the total of the number on the dice is greater than 9. Now greater than 9 means it could be 10, 11 or 12, because the maximum sum of the numbers when two dice are thrown is 12 for 6 6. There is no sum which is more than 12. So we will have to check the sum for 9, not 9, greater than 9. It is 10, 11 and 12. So for 10, it is 4 6, 5 4, 4 11, 5 6. They have mentioned all the numbers all together. So but we can check number wise. Like for first of all, we check for 10, 4 6, 5 5 6, 4 4 11, 5 6 6 5, and then for 12 6 6. Here they have mentioned along to the according to row. First they have checked from first row, second row, then third row. In first, second and third there is no sum which is our favorable. So in third row, first is 4 6, in third 5 5, 5 6, and then in next last row 6 4, 6 5 and 6 6. So total outcomes which are favorable are 6. So again probability is 6 over 36, that is 1 over 6. So similarly we can take another example, example number 10th. It is the case of coin tossing. Three identical coins are tossed together. What is the probability of obtaining? First is all heads, exactly 2 heads, exactly 1 head, at least 1 head, at least 2 head, and all the tails. So we know when 3 coins are tossed, then the possible outcomes, total number of possible outcomes is 2 raised to power 3, that is 8. And the outcomes are all head, 2 head, HHT, HTH, THH, HTT, THT, TTH and TTT. Then first is all heads. So the first part is all heads. So favorable is HHH. Similarly we can make a table like this. Favorable outcomes, all head, HHH, exactly 2 heads, HHT, HTH, THH, where only 2 heads occur, not more than 2, not less than 2. Exactly 1 head, HTT, THT, TTH at least one head or at least two head or all tails. And in second column we can mention the number of favorable outcomes 1, 3, 3, 7, 4, 1 corresponding to each favorable outcome. Then we can find the probability. So for probability of all heads, favorable outcome over total outcome, so it is 1 over 8. Then second, exactly two heads, favorable outcomes 3, total outcomes 8, so probability is 3 over 8. Exactly one head, favorable outcomes 3, total outcomes 8, again probability is 3 by 8. At least one head, favorable outcome 7, total outcomes 8, so probability is 7 over 8. At least two heads, favorable outcomes 4, total outcomes 8, so probability 4 over 8. 4 over 8 we can cancel because 4 2s are 8, so it is 1 by 2. So probability all tails. Favorable 1, total 8, so it is 1 over 8. So similarly you can go through with all the examples, and then you have to solve the sums from exercise 25b, all the sums. There are 14 sums in exercise 25b, so all the 14 sums from exercise 25b you have to complete.